Example problems. Remember, if you enjoy this channel, give us a like and subscribe. So this first question, we have a graph, and it's a velocity and time graph for an object. So we have velocity and time, and it's asking for the acceleration. And we know that the slope of a velocity time graph is acceleration. So really all this question is asking for is what's the acceleration? So if we try to find the slope, we can say that slope is equal to change in y over change in x. What's the change from -10 to 40? And that would be 50 meters per second. And the time from 0 to 5 would be 5 seconds. So the slope is 10 meters per second squared. And that, because it's the slope, is also the acceleration. Number 2, the graph shows the relationship between distance and time for a moving object. So we have this distance time graph, and they want us to sketch the graph for a velocity time graph. So we know that the slope of a distance time graph informs us about the velocity. The slope of this line is positive and constant, so the velocity has to be positive and constant. Which pair of graphs represents the vertical motion of an object falling freely from rest? So if we have an object with an initial velocity of 0, it's going to accelerate down at 9.8 meters per second squared. Okay, in this problem, all the choices are positive, so we are therefore calling down to be positive. So what would the displacement do? Well, the slope of a distance or displacement time graph tells us the velocity, and we know the velocity of a falling object is increasing, so the slope has to be increasing. So the only two choices that have an increasing slope would be these two. But it's a constant acceleration, which means the velocity has to be constantly changing. So this right here would be a constant acceleration. So the answer is choice 2. The next one says the graph below represents the relationship between velocity and time for a toy car. What's the shaded area under the line of the toy car? What does that represent? Well, we know that the area under a velocity time graph is equal to the displacement. So just by definition, that's number 1. Which graph represents the relationship between the speed of a freely falling object? This is very similar to the question we answered before. We have a ball that's accelerating down, and what happens to its speed? Well, its speed increases at an acceleration of 9.8 meters per second squared. So the speed is increasing constantly. That's going to be choice 4. Let's look at question 6. Which graph represents the motion of an object traveling with a positive velocity and a negative acceleration? So that means that the slope of the displacement time graph, which this time they're using position, but the slope of that line has to be positive to have a positive velocity. So this is positive, that's negative, and this is positive. So we know it has to be one of these two. But it says, and a negative acceleration. So the acceleration is going to be how the velocity is changing. And we can see here that the velocity is decreasing, so therefore it's a negative acceleration. Okay, we have a graph of a marble rolling down a hill, and it says what quantity is represented by the slope of the graph? Well, the slope of a velocity versus time graph, in this case speed versus time graph, is equal to the acceleration. So the question in part B is asking how far did it go in the first 3 seconds? Well, we know that the area of a velocity time graph is the displacement. So the displacement is going to be the shaded area in here of a triangle. So that's going to be area equals 1/2 base times the height. So we have 1/2 of the base is 3 seconds, and the height is 4 meters per second. And that's going to be 12. 12 times 1/2 is 6. So that's going to be 6 meters. Which diagram represents the position of the ball at equal time intervals as it falls freely from rest from the Earth's surface? So we know that when a ball first starts to fall, it's not going very fast. So it's not going to cover a lot of distance. As it speeds up, it starts to cover more distance. And then finally, when it's going very fast, it covers large amounts of distance. So the answer is number 2. Lots going on in this question. First question, determine the magnitude of the average velocity from 6 to 10 seconds. It's a little bit of a trick question. From 6 to 10 seconds, that's this time right here. And we see that the velocity is 15 meters per second. It's 15 meters per second the entire time. So the answer is just 15 meters per second. Determine the magnitude of the car's acceleration during the first 6 seconds. So from here to here, what's the acceleration? Well, we know that the acceleration is the slope of a velocity time graph. So all we have to do is find the slope. And the slope is equal to change in y over change in x. So our change in y is 15. And our change 15 meters per second, and our change in x is 6 seconds. So our slope comes out to 2.5 meters per second squared, which our slope of a velocity time graph is acceleration. So 2.5 meters per second squared is our acceleration. Identify the physical quantity represented by the shaded area on the graph. So what are we talking about when we have a velocity time graph? The area under a velocity time graph is displacement. Okay, so we have a graph of speed and time for a car moving in a straight line. So the car is going faster and faster. And the first question says, determine the magnitude of the car's acceleration. Well, we know that on a velocity time graph, the slope of the line is equal to the acceleration. So we're going to find the slope. And we should pick a nice point here where it crosses the line evenly. So right there. So we can say the change in the y-axis is 10 meters per second. And that happens over 8 seconds. And that comes out to 1.25 meters per second squared. And the slope of a velocity time graph is acceleration. So that's our acceleration. The second part of the question says, calculate the total distance the car traveled during the time interval of 4 seconds to 8 seconds. So from 4 seconds to 8 seconds, there's a couple of different ways that we can do this. So we can figure out the area under here and find that shaded area. But it's much easier in a question like this to find the average velocity for that time. So if we have 10 meters per second and this is 5 meters per second, halfway between 5 and 10 is 7.5 meters per second. And then we're going to multiply that from 4 to 8 seconds. That's a time of 4 seconds. And all we have to do is v equals d over t. So that's going to be 7.5 meters per second is equal to d over 4 seconds. And that's a displacement of 30 meters.